Does anybody research anything with the salt water or the water without any anything in it at all? And why aren't we talking about that at all? I don't understand how come that.
The problem is with the salt water, when you start making hydrogen and like with our stainless steel systems and everything, the plates just corrode.
Well, how about if you use ceramic or use something different?
Conductive plastic.
The only thing you can do is say, you know, everybody needs to go out there, go back home, and do this, and say, come on, let's go. That's about it. And then come up with your own ideas. Don't rely on all of us.
No, well,
You know
we
what I
are
mean?
all of us.
It all comes down to doing this. Getting mad, going home, and keep on playing. That's it. We don't get the answers from, you know, guessing about it or whatever. The only way you're going to get answers is just keep on playing. And hopefully you don't blow yourself up in between.
Make sure you have insurance.
The salt in the water that was reacting with that radio thing?
What is that?
The one you're talking about where you used radio frequencies to
With the salt water.
Yeah,
Yeah,
13.
he can pass it down between it. It was an amazing video.
I think
there's got to be some real phenomenal
if you crunch the numbers though, and you examine the amount of power that he needed,
Generates.
yeah, versus the amount of BTU energy released, there's a huge disparity there.
Really?
Yes, there is.
First, you have to desalinate salt water. Because salt water contains too many other minerals, irons, and precious metals.
Right, you just can't use any
Gold,
metal source. You have to use
silver,
a non-metallic source,
so on.
like ceramic. Like what they use on what they use on all of the electric poles. They use you notice they use either glass or they use like a pottery style.
Right.
They
Porcelain.
don't use metal.
Right.
And that's the key to that, because that will not conduct, and
Right.
yet it will withstand.
Let him comment.
Go ahead, please. Well, the salt water contains literally every mineral and metal that we modernly know of. I mean, the golds, the silvers, the platinums, and so on, as well as magnesium, phosphate, and so on. The first thing you have to do with salt water is desalinate it. Because if you go through electrolysis as we've been talking here, you'll begin to get, you know, every side effect imaginable, like scaling, high heat, a high amount of power required to conduct through the soil, and all that. So the byproduct is even more heat than we're getting now, so which you have to get rid of. And even more byproducts that collect on plates, be it metal or any type of conductive material. You're going to gather those ions on that plate that reacts to it, and you're going to have that scaling effect. So the first thing you have to do with salt water, basically, is to desalinate it. Now you turn it back into H2O, pure water with no element in it. Then you apply electrolysis technology to then remove, you know, the oxygen and the hydrogen from that. The goal here is that's the problem, or one of the processing problems with salt water. The amount of BTU energy required, or the amount of energy required to go into it to get the equivalent amount of HHO out that we now do is much, much higher.
Right. All right. You had a
Yeah,
question.
I know you've already said over the meeting it's impossible, but what would be the benchmark of MMWs to achieve that?
Anything higher than 7.5?
Well, there's claims out there by SMAC, which I give him a lot of credit. He's saying he's got 9 point something on 7.7 on his dry cell.
I'd like to know and be able to collect all of the data in making that determination. A, what is the temperature of the cell? Okay, and his current and his voltage across the cell, et cetera, et cetera, et cetera. Right.
How accurate is he measuring instrument?
Right.
That's something that's
Yeah,
got
We need to standardize our measurement.
Well, that's what I did with the rising bottle HH-ometer. Okay, I gave people a very simple tool to build.
That's an excellent thing for
Right, that allows them to take comparative measurements on their cells and get some idea of what the relative efficiency is, so that they can progress forward with their.
temperature being added to the MMW stuff is fairly recent, and that's to make up for people who can find themselves at 9, which is possibly impossible. It might be that they're comparing it with a temperature that's way off what everyone else is making there.
Or it could simply be that the meter that they're using to measure the amperage of the current going in is not calibrated properly. You know, a lot of people will use a shunt with an analog meter and say, "Oh yeah, see there it is." Well, no, that might be 20% off.
I had a guy with, I had a 6.3 the other day out of the fairgrounds, and I said, whoa, wait a minute. Check your amp meter there. And it's
Typically, an inductive meter that measures DC, the kind of we all can afford to buy, are probably within 20% of accurate at best. Unless you buy a $700 inductive probe and or perhaps a Hall effect.
Right.
Induction for measuring DC currents is really not effective. Shunt measuring with a precision shunt resistor, and then measure the precise voltage across that, and the meter, you know, and then it's like 50 milliwatt or 50 millivolts equals 5 amps. That's a very, very precise way of measuring current.
I've had people come to me with claims of phenomenal MMW efficiencies, but they took their amperage reading from the gauges on the front of their car battery charger.
Yeah.
Okay,
Not
so take that for what it's worth. You need calibrated instrumentation to be able to.
Instrumentation quality shunt resistors and a high quality digital voltmeter will get you much closer for our methodologies than these inductive ones that you can buy at Harbor Freight and all of that. So again, caution me for the instrumentation that we use and the calibration of that instrumentation against a known source.
If I may, I'd like to take a little break here and present Ozzy Freedom for just a moment.
Sure.
Talk about a marketing plan that he's offering, I think, to everyone. Go ahead.
Hi everyone. I wrote the books Water for Gas that inspired many people, but there's a misconcept here. People think, they come to me and say, your system. I don't have a system. I took a beginner system from Bill Lang. I found it as a great do-it-yourself thing, and from 2 years ago till now, it's always been the beginner do-it-yourself backyard mechanic as a proof of concept. I totally admire every other thing, including this one, but there's the place for the do-it-yourself and the place for the professional systems. Like we're talking about calibrating systems and stuff. Most beginners don't understand what calibration is. They just want to see that it works. And then, what next? They want the other system, or their neighbor wants the professional system.
I understand that. The one thing I have a problem with is that people that do not understand that are making claims that they do not understand to sell some product that they put together in their garage to some unsuspecting person who doesn't know, which gives the whole game a bad name.